Good morning, pilot teachers and students. Good morning, class. Good morning, sir. All right, thank you very much. You may sit down. Okay. We will be looking at the still on topic, that is on electricity. The subtopic will be electrical energy. Right, especially in a power plant or a place where the electricity is produced, let's say in a hydroelectric plant or in a power station, those that are being run by the genset generators, right? They have to produce this power, and then you'll find that the power has to go through transmission lines, and then after transmission lines, it has to go through those distribution lines before they are being taken into houses where they are being consumed, right? Consumed meaning that we are not literally eating that power, but it is used in some other ways, okay, which will be used with the appliances, right? In a house, you may have the electric stove, or you may have radios, you may have televisions. Those are some appliances which may use power. And then when you use power, you still have to pay for the usage of the power. Right? Some of you have meters which are installed in the house, in which it measures the amount of electricity which is being consumed or used. Now, there are two forms of meters which will measure the electricity going into a house. One is a dial meter, and then you find that the numbers will be moving. Okay, it goes in a form of a dial. It is only the pointer that will be moving when a certain amount of energy is being used. But then you also have the digital meter that will measure the amount of electricity that is used. So from those transmission lines, it goes to the distribution lines that will carry that into a house. In a house, especially when electricity is taken into, you will find that there are two lines which will carry that. One is a neutral wire, and the other one is a live cable that will carry electricity into a house. A neutral wire has 0 voltage, while a live wire will have very high voltage. But when it goes through that wires, it must first goes to the electricity meter, and that measures the amount of electricity that is used. Now, any appliances, especially in a circuit in a house, you will know that there are different types of circuits. There are power circuits and also other circuits that are there, right? The fuse for some of the appliances that may use large currents, for example, shower heaters and electric stove, are found on the main switch board. But others have their own fuse. For example, if you have a radio, it has its own fuse that will come from the circuits or the power points. So in this lesson, we'll go through quickly on electrical energy, and then you'll be given some activity questions that will be asking you to calculate the amount of energy that is used and also calculate the cost. Right? When you are paying for the cost, right, 1 unit is the same as 1 kilowatt hour. So energy used equals to power times the time. And when you multiply that with the cost, it gives you the amount you will have to pay for the power that you consumed. Right, so we'll go through. I'll give you some notes on that. So after the notes, there's some questions, about 4 questions that will be used as a backup of this topic. I'll quickly go through the first. All right, as I've just mentioned, electricity is usually brought into the buildings by 2 overhead wires. One is a high voltage, and it is known as a live wire, while the other is a neutral wire which has 0 voltage. Okay. This is the next. Okay, the appliances that you have in the house are connected. Okay, they are connected to those live and neutral wires, and a voltage will have to drive the current through those wires. Okay, moving on to all right, these wires will have to pass through the electricity meter. Okay, if you can copy this quickly, I will explain to you how the electricity meter has to take the reading in order for us to calculate the cost. All right, if you can look up, and especially when you are calculating the amount of energy that is used, for example, energy will be given in kilowatt hours, right? 1 unit is the same as 1 kilowatt hours. So let's say if it is 1 unit, right, it's 1 kilowatt hour. Right, in order for you to calculate that cost, then you will have to multiply that kilowatt hour with the cost of 1 unit. So let's say if you happen to come up with 2 kilowatt hours and the cost was, let's say, okay, 50 for 1 unit, right? 2 times 50 will be, okay, 1, okay, now, for 2 units and so on. Now using those dial meters, right, there are 2 electricity meters. One is a dial meter and you have another one which is a digital meter, right, that will measure the amount of electricity being used. Right, for this one which is a dial meter, you will find that there will be pointers So the first reading, when you are taking that, all right, there will be 0, 1, 2, 3, 4. It appears between 4 and 5. So your figure will be, it will be 4. And then the next will be, right, it is in the opposite direction. It is moving that way. It is 7. And then the next will be, okay, it is now moving in that direction. So you have, okay, 0. It is not at 1. So you have 470. That is the first reading. And then if you happen to get similar of this in the next reading, but this time the number has changed or it has increased because you are taking the second reading. So it will be the final reading minus the initial, which is 470. And that gives you the number in units or kilowatt hours. And then you have to multiply that with the cost to give you the amount. So after going through these notes, I will give you those activity questions which will be based on that. Right here is the next. Okay. Have you finished copying that? Okay. Okay, energy consumed in kilowatt hours will be cost power times time. For 1 hour. Right, that is your activity question. You have 2 questions. On the first slide, there will be other 2 questions given to you later. So question number 1 says a 2000 watt electric fire is used for 10 hours. Okay, what will be the cost at 10 to the per kilowatt hour or 10 to the per unit? And then for question number 2, it says a power rating of a radio is 600 watts. If used for 10 hours, what is the cost if 1 kilowatt hour is 5 toya? Okay, 1 kilowatt hour is 5 toya. Tell him to see me first. You 1 and 2. Question 1 and 2. Okay, 1, 2. Okay, you finished copying question 1 and 2?
Yes.
Okay, this should be question number 3 and 4. Okay, you have a 2 kilowatt fire and a 200 watt TV and 3 100 watt lamps. All right, they are switched on from 6 p.m. to 10, what is the cost at $8 per kilowatt hour? You go for question number 3. That one. Okay, quickly. I am going to give you question number 5. Number 4. Okay, here is question number 4. Right, for this question, maybe you can just take the reading. If you have to draw that, it's going to give you. All right, you find that there are 4 of these meters, dial meters. Right, the first one, it is in tens, hundreds, and then thousands, so on. Right, for the first one, you find that it starts from 0 and then it goes around in anti-clockwise direction. And then the next would be clockwise. And then the next again would be in anti-clockwise and so on. So you take the reading of the first and then you take the second reading. And what is the next step? Okay, good. You subtract to find the units. for number 4, that one. You start from, okay, the reading, when you take that, you start from where they are, the first, second, finish, and then you take the second reading. If the arrow is, yeah, if it is on the number, you take it straight. If you find that the arrow is on the number, right, you just take it straight from that number. Okay, quickly, only take the reading of that and then you can calculate the cost. The questions will be given to you after this. Okay, finish taking the reading from this. Okay, here are the questions. All right, only calculate the cost if one unit costs 10 toya. Okay, for question 1 and 2, okay, we get ready. Corrections will be done in a short while. So for the students who are chosen to come up and show you working out, you get ready. Okay, Nathaniel, you question 1, question 2 will be Isaac. Question 3 is Amanda. Question 4, okay, question 4A, Joe. Okay, quickly come up and then write your answers on the board. One, two, three, 4. If you want, yeah, if you want to write answers only and then you explain. Yeah. Here. Okay, you can use that. Stand by over there. When you finish, you can.
For question 1, firstly I changed the 2000 watts to kilowatts and multiplied by the time. I got a total.
Okay, that is his answer to question number 1. We'll check the answers later on. Question 2. Okay. You just give me the answer from where you are.
Uh, to find the unit, you multiply the power times the time. Power is 600 watts times 10 hours. You get 6,000 watts per watt hour. Since 5 for 1 kilowatt multiplied by 6 is 10.
All right, so the answers would be, you just stand up and then you explain. The answer to question 3 would be $80. Okay, we check that. Any other answers? Mary? Same. Okay, Michael, you have 80. Okay, 80. For question number 4, which is, okay, 2,596, 86 kilowatts. Okay, good. That is simply by looking at these scales, and then you get the reading from the first, and then using the second reading, you can minus that to give you, meaning that the second will be minus from the first reading. Okay, what is the cost? Ruli?
If you subtract the second
All right, so let's quickly go through and check our answers. All right, for the first one will be 2 kina, and then you have territory, $96, and then you have 1,200 kilowatt hours or units, and then the amount will be 120 kina. Okay, those are the answers to those questions. All right, quickly to recap on what we went through in a lesson, right, especially when power is taken into a building, the amount that is consumed must be measured, and it is upon that measurement that cost will be given. So especially when you are using power in the house, there must be a cost involved, and you'll find that there are sometimes meters that are placed in the house, like the ECP system, which is a much more improved system nowadays, in which the amount of electricity has to be taken and then measured, and using that you can calculate the cost for one of the unit. All right, so that brings us to the end of the lesson, and our key phrase for today will be electrical energy. Okay, good afternoon, pilot teachers and students. Good afternoon, class. Good afternoon, Mr. Sarek. Okay, good. You may sit.